The difference between these two joints is the difference between a 5-year lifespan and a field failure. Today we analyze why this happens and talking about solder joint fillets, which can tell us a lot about soldering quality. It does not matter whether it is manual or reflow soldering. Hello from Florida, my name is Dmitry, certified IPC specialist. The correct shape and internal condition of the fillets have a strong effects on the resistance of solder joints to vibration, dynamic loads and temperature changes. In this video you will learn how properly solder joints should look and how to recognize a critical soldering mistakes. I will not go through all IPC soldering defects. We will focus only on the sign that can be seen by the shape of the fillets. What is the solder joint fillet? It is the shape of the solder between the contact pad, the component lid and the solder joint itself. The formation of correct shape depends on sufficient heating temperature of entire joint, including the print circuit board. It also depends on the flux, which helps the molten solder flow freely and due to capillary effect form a smooth concave fillet shape. Why does the fillet shape matter? The fillet shows the level of wearing, the quality of solder contact with the metal, and indirectly tell us how correctly the metallurgical bond between the solder, the PCB pad, and the component lid was formed. It also tells us whether there were problems with temperature and cleanliness of the solder joints during reflow. A good fillet should not look like a drop placed on the top of the contact. It should have a smooth transition from the pad to the lid. A sharp angle, a spherical shape or solder that stands like a hill often indicates poor wearing and bad soldering. And right now, let's take a look at these solder joint defects. First topic, too little solder. This is the first indicator that the soldering process was violated. The joint may be stable, but its mechanical strength will not allow us to guarantee long-term reliability. With a small fillet, we can understand that the solder joint is not fixed along the full height of the component. The height and width of the fillet should be approximately the same, depending from component height. Even if there is good solder fill inside the plated hole for the component lid, a small fillet on the top is still a defect according to IPC standards. You will find more details about vias in the separate video, the link in the description, watch later. Second point, too much solder. Many people think that the more solder there is, the more reliable the joint is. This is not true. Excess solder on top in form of a ball, a sharp peak, a needle, a solder protrusion or an extension is always bad and is considered a defect according to IPC 610 standard. Too much solder on top may indicate that during solder formation the alloy did not have enough fluidity because of low temperature, insufficient flux or poor quality flux. There is a high probability that the contact of the alloy with the PCB pad and inside the plated hole is also poor, or it could also indicate a solder paste stencil that is too thick, or sloppy manual soldering. All defects have a cause. If poor wetting is visible from the outside, then inside the joint there is also be poor wetting, a weak metallurgical bond and unreliable contact. Third point, solder bridges between joints. This is an obvious defect. Excess solder can form bridges between joints. This short circuit between leads can lead to damage to some components. Bridges can be barely visible, especially when components and leads are located very densely on the print circuit board. If you design print circuit boards yourself, be sure that consider the size of the contact pads and the distance between them, according with IPC standards. Point 4. Insufficient solder fill in plated holes. Carefully inspect both sides of one lid. If this is a component lid passing through a plated hole, then the fillet on both sides must have a correct shape. This tells us that the hole is fully filled with solder, and the solder has formed a joint with the hole plating. If this is a connector lid that by design does not come out on the back side of the board, then it is enough for us to see that the hole is filled with solder, and that a normal fillet has formed on the connector side with a reliable joint between the solder, the lid and the hole plating. A very important detail, the lid is cut at the top of the solder joint, and after that this lid must be soldered again to thin the exposed cut metal of the lid. Otherwise, you risk seeing rust on the cut section. More about this in my video about PCB rust, the link in the description. Point 5. Turn fillet edges due to delamination on the pad or component. The quality of the joint between the solder, the PCB pad and the component tell us about surface contamination, the presence of oxide or delamination. This is 100% defect according to IPC and cannot be considered a reliable joint. The soldered surfaces must be clean, without obvious oxide spots, without delamination and degreased. In one word, clean. Otherwise, there is a high probability that the joint will not withstand dynamic loads during device operation and the solder joint could come loose. If there is no way to properly restore the PCB contact pad, always use fixing adhesive for the component. And if the surface of the component itself is bad, it's better to buy a new one. Point 6. Visible base metal of the contact pad after soldering. This is also a defect according to IPC. Visible base metal areas of the contact pad after soldering tell us either about insufficient wettability of the surface by the flux or about contamination on the contact pad. The solder must fully cover the required soldering area of the contact pad without exposed areas, maybe a little bit on the edge of the pad. Small notification: if you are not subscribed to my channel, then now is the time to subscribe and like this video. Point 7. Cold solder joint. From the definition itself, it follows that during solder reflow the temperature was insufficient. A cold solder joint may look normal, but with careful inspection under a microscope, you can notice a gap between the contact pad and the solder, or between component lid and the solder. Three bodies participate in the creation of solder joint: the print circuit board, the component, and the solder. The print circuit board is most often the body with the highest thermal mass. Therefore, for regular soldering, I recommend using the correct soldering iron tip temperatures: 320 degrees Celsius for leaded alloys and 350 degrees Celsius for lead-free alloys. Use a regular 2 mm wave tip. More details are in the video about soldering temperatures, the link in the description. Point 8. Solder overheating. In this case, the color of solder joints becomes darker. This is 100% defect, which indicates that the soldering area, including the components, the print circuit boards, and the traces, was exposed to high temperature. As a result, this area of the print circuit board most likely received hidden cracks in the laminate, and the reliability of solder joint became much worse. The soldered components was exposed to overheating, and the soldering temperature exceeded the limits allowed by manufacturer, which also affects the preservation of the component's internal structure and its correct future operation. If this print circuit board is responsible for critical processes in human life, then it must not be released from production and must be rejected as defective. Point 9. Hidden defects. The external appearance cannot always honestly tell us about the quality of all connections inside. I first evaluate the outside. A good microscope is needed. It is necessary to inspect the joints from different angles to make sure that all fillets are correctly formed, that all joints are soldered, that they have the correct fillet shapes. When through-hole lids are present, we must always look at the back side of the print circuit board. The solder must be visible. But the presence of solder alone is not enough. It must not simply fill the hole like a plug. The solder must be joined to the walls of the plated hole and to the contact pad on the surface of the print circuit board. For joints under microcircuits, the most reliable inspection method is X-ray. Of course, X-ray is only used in manufacturing. In our conditions, we can use only soldering technologies: microscopes, correct temperatures, high-quality solders and solder pastes, fluxes, and clean surfaces. Thank you for watching this video to the end. Like this video and write about your soldering experience in the comments. We are all very interested to hear about your experience. All links from the video are in the description. Support my channel on Patreon. For those who want to use high-quality fluxes, under the video you will find links to my diamond flux products. You can buy them online through Amazon, Walmart, and DGK. Thank you for watching. See you next video.